of point L, and then using the distance formula we calculate the distance PL. Now let's try to find out how to find the image of a point in a straight line. So let us say that this is the straight line, and let us say any point P alpha comma beta comma gamma. We have to find the image of this point about this line. Let us say that its image is P dash, the coordinates of which are alpha dash, B dash and gamma dash, which we need to find. Now let us say that the equation of this line is x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Let us take any point L on this line, the coordinates of which become lambda times A plus x1, lambda times B plus y1 and lambda times C plus z1. Now we see that PL is perpendicular to this line. So from this we find out the value of lambda. Also we see that this line acts as a mirror. So L would be the midpoint of PP dash. If we join this segment PP dash, then PL is equal to half of PP dash, and thus L is the midpoint of PP dash. So using the midpoint formula we get alpha plus alpha dash by 2 equal to lambda times A plus x1, beta plus beta dash by 2 equal to lambda times B plus y1, and gamma plus gamma dash by 2 equal to lambda times C plus z1. So from this we calculate the values of alpha dash, B dash and gamma dash, and thus we get the final coordinates of the point P dash, which is the image of this point P about any given line. Now let's try to solve an example. Find the image of the point 1, 6, 3 in the line x by 1 equal to y minus 1 by 2 equal to z minus 2 by 3. So in this problem we have to find the image of the point 1, 6, 3 about the line, the equation of which is x by 1 equal to y minus 1 by 2, which is equal to z minus 2 by 3. So let us say that P be the given point and L is the foot of the perpendicular from point P on the given line. So the general coordinates of the line are given by x minus 0 by 1 equal to y minus 1 by 2 equal to z minus 2 by 3 equal to, let us say, lambda. So the general coordinates would be x equal to lambda, y equal to 2 lambda plus 1 and z equal to 3 lambda plus 2. Now the direction ratio of PL, which is perpendicular to the line, become lambda minus 1, 2 lambda minus 5 and 3 lambda minus 1. Also the direction ratios of the lines are 1, 2 and 3. Also we know that these two lines are perpendicular to each other. So lambda minus 1 into 1 plus 2 lambda minus 5 into 2 plus 3 lambda minus 1 into 3 would be equal to 0, and from this we get lambda equal to 1. And so the coordinates of L are 1, 3, 5. Now we know the coordinates of point P, we know the coordinates of point L. So using the midpoint formula we calculate the coordinates of the image. Now let us assume that A, B, C are the coordinates of the point Q, which is the image of the point P. So A plus 1 by 2 would be equal to 1, B plus 6 by 2 would be equal to 3 and C plus 3 by 2 equal to 5. Thus the coordinates A, B, C are 1, 0, 7. So we can say that the image of the point P is Q, the coordinates of which are 1, 0, 7. Now skew lines. What do we mean by skew lines? The lines which are neither parallel nor intersecting are called as skew lines, or we can say that lines which do not lie in the same plane are called as skew lines. So let us see this figure. This line L1 lies in this plane, and we have another line L2 which is perpendicular to this plane. Thus we see that these two lines do not lie in the same plane, and thus lines L1 and L2 are neither intersecting lines, neither they are parallel. So such a pair of lines are called as skew lines. Also we see that this distance is the shortest distance between any 2 points on these lines. This is the perpendicular distance between the lines L1 and L2, and so this distance is known as the shortest distance. Thus we can say that skew lines are lines which are neither parallel nor intersecting, or these are the lines which do not lie in the same plane. An example of this is the lines L1 and L2. L1 lies on this plane, L2 lies on a plane which is perpendicular to this line. Therefore L1 and L2 are skew lines. Also this yellow segment is perpendicular to both these lines L1 and L2, and hence this is the shortest distance. Now let's try to find out the shortest distance between two skew lines. So first, in the vector form we are going to find the shortest distance. Let us say that this is the line L1 and this is the line L2, and both these lines are skew lines, that is, they do not intersect nor are parallel to each other. They lie in different planes. So let us say that the equation of L1 is vector r equal to vector a1 plus lambda times vector b1. Let us say that a is the point through which this line passes and the position vector of this point is a1. Similarly, we have another line L2. The equation of which is vector r equal to vector a2 plus mu times vector b2. So this is the line that passes through the point B with the position vector as a2, and this line is parallel to a vector b2. Now we have to find the shortest distance between these two lines. So for that, let us say that PQ represents the shortest distance between these two lines L1 and L2. Now for shortest distance, PQ must be perpendicular to both these lines L1 and L2, and thus PQ would be parallel to B1 cross B2. This is because this line is parallel to B1, this line is parallel to B2, and so a line which is perpendicular to both B1 and B2 is B1 cross B2. Thus PQ becomes parallel to B1 cross B2. Also, if we try to find out the unit vector along PQ, then it is n cap equal to B1 cross B2 divided by the modulus of B1 cross B2. So if we divide this vector by the modulus of this vector, then we get a unit vector which is perpendicular to both B1 and B2 and hence is along the vector PQ. So we have found out the direction of PQ. Now we have to find out its magnitude. The magnitude of PQ is the projection of AB on PQ. So we have this distance AB. If we find the projection of this line on PQ, then that would be the length of PQ, and hence that would be equal to the shortest distance between L1 and L2. So PQ vector would be equal to AB vector dot n cap. Now we know that AB is nothing but A2 vector minus A1 vector, as the position vector of point B is A2 and the position vector of point A is A1. So this would be vector A2 minus vector A1, and n cap is B1 cross B2 divided by modulus of B1 cross B2. Thus the shortest distance becomes the magnitude of the vector PQ, and that is equal to the modulus of B1 cross B2 dot A2 vector minus A1 vector divided by the modulus of B1 cross B2. Now this is nothing but scalar triple product. Therefore, it could be written as the box product of B1 vector, B2 vector and A2 vector minus A1 vector, and this divided by the magnitude of B1 cross B2. Thus the shortest distance becomes the magnitude of the box B1 vector, B2 vector and the vector A2 minus A1 divided by the modulus of B1 cross B2 vector. Now what if the two lines intersect each other? Then the shortest distance would be equal to 0, because the two lines are intersecting each other. Thus the shortest distance becomes equal to 0, and so the box product of B1, B2 and A2 minus A1 is equal to 0. Thus we can say that if the box product of the vectors B1, B2 and A2 minus A1 is equal to 0, then the two skew lines intersect each other, and so the shortest distance between them is equal to 0. Now let's try to convert it to the Cartesian form. Let the equation of two skew lines be x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1, and x minus x2 by a2 equal to y minus y2 by b2 equal to z minus z2 by c2. So these are the equations of two skew lines. Now if we express these lines as vectors, then vector r would be x1 times I cap plus y1 times j cap plus z1 times k cap plus lambda times a1 I cap plus b1 j cap plus c1 k cap, and r would be equal to x2 I cap plus y2 j cap plus z2 k cap plus mu times a2 I cap plus b2 j cap plus c2 k cap. Thus we have expressed these two lines as a vector form of equation of these two lines. Now we know that the shortest distance is modulus of a2 minus a1 dot b1 cross b2 divided by the modulus of b1 cross b2. Now a1 is x1 I cap plus y1 j cap plus z1 k cap, a2 vector is x2 I cap plus y2 j cap plus z2 k cap, b1 vector is a1 I cap plus b1 j cap plus c1 k cap, and b2 vector is a2 I cap plus b2 j cap plus c2 k cap. So if we substitute these values over here, we get the shortest distance. Now if we say that the two lines intersect each other, then the shortest distance is equal to 0, and thus the box product of b1, b2 and a2 minus a1 is equal to 0. And thus we get the condition as the determinant, elements of which are x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1 and a2 b2 c2 is equal to 0. Thus we can say that for intersecting lines, shortest distance is equal to 0, and hence the determinant, elements of which are x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 is equal to 0. Now let's try to find out the shortest distance between two parallel lines. Let us say that this is line L1 and this is line L2. Clearly L1 and L2 are two parallel lines. Let this line pass through the point S, position vector of which is A1, and this line passes through the point T, the position vector of which is A2. Now we clearly see that PT is the shortest distance between these two lines, as this line TP is perpendicular to both these two lines L1 and L2. Now let us say that the vector equation of the first line L1 is vector A1 plus lambda times vector B, and similarly the vector equation of this line is vector R equal to vector A2 plus mu times vector B. Now the shortest distance is equal to the modulus of vector A2 minus A1 cross vector B divided by the modulus of vector B. Thus we can say that the shortest distance is given by the formula modulus of A2 minus A1 cross vector B divided by modulus of vector B. Thus if two lines are represented by the vector equations A1 vector plus lambda times vector B, and the second equation is vector R equal to vector A2 plus mu times vector B, then the shortest distance between these two lines is given by this formula. Now once again let's try to solve an example. A line from the origin meets the line x minus 2 by 1 equal to y minus 1 by minus 2 equal to z plus 1 by 1, and x minus 8 by 3 divided by 2 equal to y plus 3 divided by minus 1 equal to z minus 1 by 1 at the point P and Q respectively. If the length of PQ is equal to d, then d square is. So here it has been given that there is a line from the origin and this line meets these two lines at the points P and Q. Given that the length of PQ is equal to d, find the value of d square. So let us assume that this line is x by a equal to y by b equal to z by c. Your a, b, c are the direction ratios of this line, and this line passes through origin. We have been given that this line and the first line intersect each other. So for intersecting lines, b1 cross b2 into a2 minus a1 is equal to 0. So what we do is, taking the first line and the assumed line, we find this value, which is a times I cap plus b times j cap plus c times k cap cross I minus 2j plus k dot 2I cap plus j cap minus k cap minus 0 times I cap plus 0 times j cap plus 0 times k cap equal to 0. So what we have done here is, we have taken b1 vector as a times I cap plus b times j cap plus c times k cap, as the direction ratios of this line are a, b, c. The direction ratios of the first line, that is, this line is 1, minus 2 and 1, and hence we can write this vector as I cap minus 2j cap plus k cap into a2 minus a1. a2 is the point through which this first line passes, and that is 2, 1 and minus 1. Thus we can express that point in the vector form as 2I cap plus j cap minus k cap minus 0 times I cap plus 0 times j cap plus 0 times k cap, because this line passes through the origin with the coordinates 0, 0, 0. So when we solve this, we get 2 times b plus 2c plus c minus a minus of minus 2a minus b equal to 0, or a plus 3b plus 5c equal to 0. Similarly, when we solve the assumed equation with the second line, we get 3 times a plus b minus 5c equal to 0. So from this equation and from this equation, we get a by 5 equal to b by 5 equal to c by 2. Thus the direction ratios are 5, 5 and 2, and hence the equation of line becomes x by 5 equal to y by 5 equal to z by 2. Thus this is the equation of the assumed line.